So now that we can locate all the angles around the unit circle, we want to talk about a quick way to find sines and cosines of the angles. We're going to start by just looking at quadrant 1, and then we're going to move on to how to kind of generalize that to all the other quadrants. First of all, to deal with pi over 6, or 30 degrees. Well, let's see, if I draw out a 30, 60, 90 right triangle, the point of the unit circle is it's a circle with a radius of 1. So when I'm somewhere around my unit circle, these things over here, those are just 1. I want to focus on the sine and cosine of this angle over here. I know the hypotenuse of the right triangle that I can make is 1. From what I know about 30, 60, 90 right triangles, what's across from the 90 is 2x, what's across from the 30 is x, what's across from the 60 is x root 3. Well, if 2x is 1, I know x is going to have to be 1/2. And I know that what's across from the 60, x root 3, has to be 1/2 root 3, or root 3 over 2. Now, the sine of 30 degrees is the opposite over the hypotenuse, 1/2 over 1, or just 1/2. The cosine of 30 degrees, by the way, I probably shouldn't be using 30 degrees, I should probably be using pi over 6, but it's all kind of the same deal. The cosine is the adjacent over the hypotenuse, so root 3 over 2 over 1, or root 3 over 2. Moving on to the next good angle around the unit circle. No, you know what? Before I do that, this point over here, notice that the x-coordinate of my point is root 3 over 2, the y-coordinate of my point is 1/2. Well, those are just my sines and my cosines. What did we just say the x-coordinate was? We said it was root 3 over 2, and what did we say the y-coordinate was? 1/2. Really, where we're eventually going with this is all of the x-coordinates of the angles around the unit circle will be the cosine of that angle, and the y-coordinate will be the sine of that angle. When we're around the unit circle, x comma y equals the cosine of my angle, comma the sine of my angle. Let me move on and try to find the coordinates of this point over here. So I can make a right triangle and all that stuff. And I want to try to find the coordinates of this point. Well, I know at pi over 4, or 45 degrees, I can make a right triangle that looks like this. 45 degrees, 45 degrees. I've got a 45, 45, 90 right triangle. My hypotenuse is 1. I know that what's across from the 45 is x, the other 45 is also x. What's across from the 90 is x root 2. So I can do a little bit of work. I can say x root 2 equals 1, divide by root 2, divide by root 2, x equals 1 over root 2, multiply by root 2 over root 2. X is going to be root 2 over 2. I know this side of the triangle is root 2 over 2. I know this side is root 2 over 2, which means to get to this point over here, horizontally you'll go out root 2 over 2. Vertically, you'll go up root 2 over 2, which means the cosine of pi over 4 is root 2 over 2, and the sine of pi over 4 is root 2 over 2. Pi over 3, or 60 degrees. Well, I can draw it out like this. Obviously not drawn to scale. I can put a 60 there, a 30 there. That's 1. I know again, what's across from the 90 is 2x. This is x root 3. So I know this side over here has to be 1/2, this side over here has to be root 3 over 2, which means the coordinates of my point over here, what did I say over here? I said I was going over 1/2 and up root 3 over 2. I can say my coordinates are 1/2, comma root 3 over 2. Finishing off quadrant 1, 0 radians, well, remember we're on the unit circle, circle with a radius of 1. 0 radians, I think my coordinates there are going to be 1, comma 0. Pi over 2, you're going straight up, you're not going over at all. I think my coordinates are 0, comma 1. And again, if we just know our coordinates, we will be able to find our sine and our cosine very quickly if we just remember that the cosine is the x and the sine is the y. Now, there are 1, 2, 3, 4, 5 different options for the cosine, and 1, 2, 3, 4, 5 different options for the sine, the same options over there. You should notice that the only options we have are 0, 1/2, root 2 over 2, root 3 over 2, and 1. Or another way of looking at this is root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, and root 4 over 2. 0 is obviously the smallest, 1 is obviously the largest. What I'm noticing over here is as I go from 0 to pi over 2, my y-coordinate starts from the smallest thing and increases. This y-coordinate is 0. This one just a little above horizontal is the next biggest y-coordinate, 1/2. Then root 2 over 2, then root 3 over 2, then root 4 over 2, or 1. As I move along my unit circle, my y's are increasing. Also, as I move along the unit circle, my x's seem to be decreasing. This has my biggest x, 1. This is my next biggest x, root 3 over 2, then root 2 over 2, then 1/2, then 0. We can use these unit circle ideas combined with sort of the idea of there are only 5 options here. Do I want the biggest? Or do I want just 1, or do I want 0? Do I want the biggest answer that's not 1? Do I want the smallest value that's not 0? Do I want the one right in the middle? And I can kind of use some of those logic things to help me figure out what's going on. Biggest x value is 1. Root 3 over 2, root 2 over 2, 1/2, 0. Smallest y value is 0, then 1/2, then root 2 over 2, then root 3 over 2, then 1. In the next video, we're going to see how we can generalize these ideas to the other quadrants.